Okay, if you'll remember, a couple of lessons ago, we did a double reflection around two intersecting lines, and that created rotation. So there was a rotation from triangle ABC to triangle A double prime, B double prime, C double prime. Now, the amount of rotation, the number of degrees that it went, remember, was twice the number of degrees as that intersection between the two lines, M1 and M2. And so that'll be important for what we're looking at today with rotations in the coordinate plane. Go to the next page. All right, so we're going to be exploring a particular rotation around the origin, which remember is just the point 0, 0. Remember, a rotation about the point of intersection of two lines is a composition of two reflections across those lines, and that's what we did in that previous activity. Keep in mind that the coordinate axes intersect at a 90-degree angle. So we're going to use this activity to look at the composition of two reflections across the x and the y axis. Okay, so I'm going to drag one of these polygons, and I'm going to drag the pentagon. I just think it's easier to see what's going on with that particular shape. So come on over, pentagon. There we go. Okay, so you can see the coordinates of the pentagon right here, 13, 15, 17, 11, 15, 7, 11, 7, 9, 11. So we already know what should happen when I reflect this across the x-axis. We've already learned that that will change the sign on the y. So you can see that's exactly what happened. Every y coordinate changed its sign. It was positive, now it's negative. Now we're going to take this image pentagon and reflect it across the y-axis. So we already know what should happen. The x-coordinate should change its signs, and that's exactly what happened. Now these are negative. So the reflected coordinates that are given here are of this image in compared to our original figure. So these are the original coordinates, and this is after being reflected over both the x and the y-axis. The y changed signs when we reflected across x, and then the x changed signs when we reflected across y. Now I'm going to show you what happens when we do a 180-degree rotation around the origin. So here is my pentagon. Remember, the counterclockwise is the natural progression around a coordinate plane. And look, it ends up exactly where our figure did after that double reflection. So let's see, did it just so happen that that happened just because of where I placed that pentagon? And you would probably guess that no, it had nothing to do with it just being from the pentagon. So I'm going to put my pentagon over here in my second quadrant. So in the second quadrant, the x is already negative, the y is positive. So when I reflect across the x, we know that should change the sign on the y, which it did. All these positive y's became negative. Now I'm going to reflect this image one across the y-axis, so the x should change signs. And notice they all became positive. So now compare where the original coordinates were to the reflected, double reflected image did. So the x changed signs and the y changed signs. So if I show a 180-degree rotation, again it went counterclockwise because that's the natural progression. It ends up exactly where our double reflected figure did. So let's look at our question 5 in our notes. So if you took a point B, it says, and you took B and it was at 3, 1, and you can see that in this figure here, and we do a 180-degree rotation, we know that's the same thing as a double reflection. So if we reflected 3, 1 across the x-axis, it would become 3, negative 1. If we take 3, negative 1 and reflect it across the y, it becomes negative 3, negative 1. So how could we go directly from 3, 1 to negative 3, negative 1? What's the rule for a 180-degree rotation? Well, notice 3, 1 becomes negative 3, negative 1. The x and the y both change signs. So question number 5 on your note says, write an ordered pair rule for the rotation of point B if we just have a general point x, y, and we're going 180 degrees around the origin. So when you write an ordered pair rule, you're always going to start with your generic point x, y. You draw an arrow to show you're mapping it to new points, and then you're going to give the rule. What are you doing to the x? What are you doing to the y? Well, in our case, we want x to change signs, so we're going to put that negative sign in front of x, but remember, we're going to say that means opposite of x. And then we also change the sign on the y, so we're going to put a negative in front of the y to show it's changing signs as well. But remember, the original point could have had one of, or both of those be negative, and so this would make them become positive. So for example, if I started with the point -6, 12, and I did a 180 degree rotation around the origin, that point would become +6, -12. They both change signs. So the -6 became a +6. So this means opposite of x, opposite of y. Alright, so let's look at our next slide. It says, does the order you choose between the axes of reflection matter? In other words, if you reflect across the x-axis first and then the y, is that different than if you started reflecting across the y-axis and then did the x-axis? So let's just take a point and talk about that for just a minute. So if I took the point 3, -5 across the x-axis, I know it's going to change the sign on y, so that's going to become 3, 5. If I take 3, 5 and I reflect it across the y-axis, it's going to change the sign on x, so it becomes -3, 5. So I first reflected across the x, and then I reflected across the y. So let's change it the other way. Let's start with 3, -5, and let's reflect across the y first. Well, we know it's going to change the sign on x, so that becomes -3, -5. Now, let's reflect across the x-axis, which means the y is going to change signs. So that's going to become -3, 5. You can see we got the same result. So no, the order that you reflect over the axes does not matter. Both of the coordinates are going to change signs. All right, let's look at number 6 on your notes here. These are our answer choices, and we're going to tell what this is the ordered pair rule, which remember is also called coordinate notation. It's written in the ordered pair rule, and we have to tell what transformation occurred. Now, it's given in A's and B's instead of X's and Y's, and that does not matter. It's the same thing. This is your X, this is your Y, and we're telling what's happening to those coordinates. So let's look what's going on with the first one. It says the point AB is being mapped to the point BA. So you can see they're switching places. So which transformation did we learn today where the X and the Y switch places? Remember, that was the very first one we looked at. That's the reflection across the line y equals x. Reflection across y equals x. And you can see in the equation itself, do you see the y first and then the x? Maybe that'll help you remember that that's what happens. The x and y switch places. The y coordinate is now first and the x coordinate is then second. Okay, let's look at our next one. The point AB is being mapped to, and remember that's what we're going to say is the opposite of A and then B. So the x coordinate is changing signs. So that's a left or right movement, so that is a reflection across the y-axis. So reflection across the y-axis changes the sign on the x coordinate because you're going left to right, right to left. The next one says we're mapping AB to A opposite B. So the y coordinate is changing signs. So that's an up and down movement if you're changing the sign on y. So we're reflecting across the x-axis. Reflection across the x-axis changes the sign on y. The next says that you're taking the point AB and mapping it to opposite of A, opposite of B. So you're changing the sign on both your x and your y. And that's the one we just got finished looking at. Remember, that's the double reflection over both axes, but that's equivalent to a rotation of 180 degrees about the origin, point 0, 0. That changes the sign on x and y. And then this one is not one that we've gotten to yet, but we're going to talk about it in just a minute. What happens, what transformation is occurring if you take a point and not only do the x and y change places, but they change signs at the same time? At this point, that doesn't match the transformation that we have been given, but we'll talk about which one that is in just a moment. Doesn't match a given transformation. So we have one where they switch places. That's the reflection across y equals x. We have one where both of them change signs. That's the rotation of 180 degrees around the origin. But there is one that exists that does both. Changes their position and their signs at the same time. Before we get that, I want to just have you do a little bit of prediction. If your pre-image starts in quadrant 2, which is in this top left quadrant where the x is negative and the y is positive, where will it end up after the composition of the two reflections? Or in other words, where will it end after a 180 degree rotation around the origin? So remember, our natural progression is counterclockwise, and every time you go 90 degrees, you go one quadrant over. And so that was 90 degrees, here's 180. So if it started in the second quadrant, it's going to end up in the... All right, so our final question today is going to be to that last one that we talked about that we said we don't have a transformation for yet. The question is, what would be an ordered pair rule for reflecting across the line y equals negative x? So let's talk about that. I've written that on my notes, and you can feel free to add that to your notes there. What is the ordered pair rule for reflecting across the line y equals negative x? First of all, let's talk about what that would look like on the coordinate plane. So this is in slope-intercept form. This time we have a negative sign in front of the x, and we know that's the same thing as a -1. We don't have a constant, but we just means that we know that means that our y-intercept is 0. So we're starting at 0, but this time our slope is negative, so it should be going downhill. So we could put that over 1 and understand we're going down 1, right 1, down 1, right 1. The line would look like this, a -1 slope as opposed to a +1 slope. So if we started with a triangle here and reflected across this line, we could see we're going to end up in this quadrant over here. So this is where x and y are positive, and this is where x and y are both negative. So we know they're going to change signs, but it's not the same thing as a 180 degree rotation where you just change the signs and that's it. This is the rule for the reflection across the line y equals negative x. So if we want to write an ordered pair rule where we start with x, y, what that looks like is y and x switch places, and at the same time they change signs. So we're going to have the opposite of the y coordinate in the x place and the opposite of the x coordinate in the y position. So this is the ordered pair rule for reflecting across the line y equals negative x instead of y equals x. All right, have a great day.